Welcome, geometry students, to section 11.1, space figures and cross sections. So this is going to start our exploration of three-dimensional figures. So let's define some things here first. All right. A blank is a segment that is formed by the intersection of two faces. Well, that is an edge. A blank is a point where two or more edges intersect. So where two edges intersect, that is a vertex. A cube has 8 vertices. And a cube has 12 edges. All right. Okay. Polyhedron. Polyhedron is the name for a three-dimensional object. It's a space figure or a three-dimensional figure whose surfaces are polygons. So that's the important part, all right? Because it's poly, all right, we got to think that the sides, which are actually referred to as faces, all right, those are all polygons. So in this prism here, all right, in the prism, those are all rectangular. Here in this pyramid, all right, in this case, this type of pyramid, all of these are triangular. All right, so the word polyhedron combines the Greek prefix poly, which means many, and hedron, which means bases. The reason it means many bases is because if I take this prism right here and I even rotate it, then which one is the base? Or if I rotate it again, which one is the base? Remember, base does not mean bottom. All right, now in a pyramid, now this one it actually is a different kind, but in some other pyramids, we know which one the base is. We'll get to that as we work. Okay. All right, things that are not polyhedron are circles, cylinders, and spheres. The reason they are not is because their faces are not polygons. All right, they are something separate. So cross are the figures that are not polyhedron. All right, this one is not a polyhedron, but the rest of them are. If you look at the faces of each one of them, they're all polygons. All right, so here's an example of the pyramid where I know this one is the base. So I would call that a square pyramid. Okay. Now, what's the base of this prism? Anybody know what the shape of the base of that is? It is a triangle. All right, it's a triangle. So this is actually on its side. Okay, this is actually on one of its sides. So the base have to be congruent figures. Okay, all right. Identify vertices, edges, and faces. How many vertices, edges, and faces are in the polyhedron at the right, and list them. So identify each description as a vertex, an edge, or a face. A point where 3 or more edges intersect. We call that a vertex. Okay. Polygon. Well, a polygon, those are the faces, and a segment where 2 or more faces intersect, we call that an edge. All right, so list the vertices. So our vertices are all these points, okay, right there. So our vertices are going to be S, R, V, W, T, and U, okay? List all the edges. So the edges are the sides of the polygons. So there's some edges right there. So we can list all those segments. So segment RS, segment SW, segment WV, and segment VR. Okay. Other edges we have the bottom edge here. So we have those. All right. So we have segment UV, segment UT, and segment TW. And then don't forget about these vertical pieces right here. So we have segment RU and segment ST. Okay. All right. Now we want to list the faces. So the faces are all, again, sides is what you would think they are called, but they're not. They're called faces. So how about the name of the bottom one? All right. So the bottom one is, let's see, I have a quadrilateral UVWT. All right. How about this slanted face right there? That is another quadrilateral, RVWS. How about this back wall over there? All right, I've got RSTU. All right, and then I've got these two triangular bases as well, all right, which is going to be RUV, so triangle RUV, and triangle STW. Okay, STW. Okay, so count them up. How many are there? All right, how many are there? Well, there are 6 vertices. So we count them up: 1, 2, 3, 4, 5, 6. Edges. All right, how many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 edges. And then faces: 1, 2, 3, 4, 5. Okay, so there we have it. All right. All right, pause the video and try this one on your own. Tell me how many vertices, how many, or what the vertices are, how many, and how many edges, and how many faces. All right, go ahead, pause the video and do that. Okay, let's look at vertices. So vertices, I've got 5 of them, right? So I've got G, F, E, and D, and H is actually called the vertex of the pyramid. All right. Okay, so there's 5 of them total. All right. Next, edges. Okay, well, let's go around the square base first. So I have DE, EF, FG, GD. All right, so that's the 4 around, and then I have all these sides that are going up. All right, to the pyramid's vertex. So I have all of those as well. Okay, so that's going to be DH, EH, FH, and GH for a total of 8. Okay, all right, and then faces. How many faces do we have? All right, well, we have the rectangle. It kind of looks like a square. All right, it could be. All right, a square pyramid. Usually we have to define it or know it's a square. All right, so I have DEFG. All right, that quadrilateral, and then I have my 4 triangles. So I have triangle DEH, triangle EFH, triangle FGH, and triangle DGH. Okay, for a total of 5. Okay, all right, excellent. Okay, so Euler's formula. No, it's not pronounced Euler, even though some of you are probably like Euclid. All right, it's not. It's actually pronounced Euler. The sum of the numbers of the faces F and the vertices V of a polyhedron is 2 more than the number of its edges. F plus V equals E plus 2. So the faces plus the vertices is equal to the edge plus 2. Look back at what we just did. All right, so faces plus vertices. Faces plus vertices is equal to edge plus 2. Look at the number of the faces we had. Number of faces we had was 5. The number of vertices we had was 5. The number of edges we had was 8. And then we had 2. So that's 10 equals 10. You can see it works. All right? So if I look back at this one, F plus V equals E plus 2. All right? The number of faces. Down here we had 5. Vertices, we had 6. All right, edges, we had 9 plus 2, we had 11 equals 11. That's going to work 100% of the time. All right, so let's take a look at this example right here. Use Euler's formula to find the number of faces for the polyhedron with 30 edges and 20 vertices. Okay, so we have 2 values we can plug in. Now we only have 1 unknown value. All right, so we have 20 vertices, and we have 30 edges. So now I can solve for F. All right, so F plus 20 is equal to 32. All right, we'll subtract 20 to the other side. So 32 minus 20 is going to give us 12. So I know the polygon with 30 edges and 20 vertices is going to have 12 faces. All right. So you can see in this example here we've got a whole bunch of pentagons. There's 12 of those in this figure. Okay. All right, go ahead and pause the video and try this one. How many faces, vertices, and edges does the polyhedron at the right have? And we're going to justify it by Euler's formula. All right, so go ahead. Okay, F plus V equals E plus 2. So we're going to count our faces here first, right? So if we count our faces, I have the bottom and the top, and then I have 6 that go around all right, this way, right? I have 6 that go around that way, okay? So that is 6 plus 2, all right, which gives us 8. Okay, so there's 8 faces. Vertices. Count the vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? Edges. All right, now we'll count our edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then I have this plus 2. Let's see if it all fits. All right, does this fit into Euler's formula? Here I have 20 equals 20. It works. So I know I counted right. Okay? All right. Good. Next, in 2 dimensions, Euler's formula reduces to f plus v equals e plus 1. All right? So now, in this case, it turns into plus 1 if it's in 2 dimensions. Well, if it's in 2 dimensions, then what we want to look at is we want to look at the net. All right? We want to look at the net of the formula, or net of the object. So how can you verify Euler's formula for a net in the solid in problem number 2? So here's our solid right here. So first off, can you draw that in 2 dimensions? Go ahead and pause the video and take a minute to draw that in 2 dimensions as a net. Okay. All right, let's take a look. So if I draw that as a net, what's it going to look like? Well, my lateral area is going to look like this, where I'm going to have 6 of these rectangles. Right? I've got 6 of those, and those are all the sides that go around. And then off one of these, I'm going to have a hexagon, right? For the top, all right? And then off another one for the bottom, or we can do it off the same one, it doesn't matter. So that's what our net looks like, okay? So if I would kind of wrap this around this way, fold this up, this would be my result, right? Okay, so what I want to do now is I'm going to use Euler's formula for 2 dimensions. And it says f plus v equals e plus 2. So I'm going to count my faces. So my faces are 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's going to be 8 plus. Now my vertices. I'm going to count my vertices. All right. So let's see what we got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay? Equals edges. All right, now we're going to count my edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay? All right. Okay? So, excuse me, plus 1. That's going to be plus 1 because we're in 2 dimensions now, right? Okay? So we want that to be a 1. All right? So let's see if it works. I get 30 equals 30. It works. All right? So that's how we verify Euler's formula in 1 dimension. Okay? All right. Go ahead and pause the video and verify Euler's formula. And now we're back to 2 dimensions. Since we have a polyhedron this time instead of a net. All right? Go for it. Pause it. Okay, let's take a look. Solid to right, how can you verify Euler's formula? F plus V equals E plus 2 for a solid. Count the number of vertices. All right, so a number of vertices. Well, there's 4 on the bottom, right? 1, 2, 3, 4. Plus 4 on the top. 1, 2, 3, 4. So that's 8 vertices total. Count the number of faces. All right, the number of faces. Well, I have what looks to be like the bottom and the top. And then I've got 4 that go around the sides there, right? Okay, so I'm going to have 2 bases and 4 lateral faces for a total of 6. All right, now let's count the number of edges. the number of edges, solid edges. So if I count over here, 1, 2, 3, 4, 5, 6, 7, 8, 9 solid edges. All right, and then there's 3 dashed ones. Right, so for a total of 12. Okay, so if I do F plus V equals E plus 2, I'm going to have 6 plus 8, 6 faces and 8 vertices. All right, and then I have 12 edges. So that's going to be 14 equals 14. So it works. We did it. Okay. All right, good. Next thing we're looking at is a cross section. The cross section is the intersection of a solid and a plane. You can think of a cross section as a very thin slice of a solid. All right. If you ever have played Fruit Ninja, all right, then when you cut those pieces or cut those fruit in half, all right, you can see the slice. All right, so it's exactly what a cross section is. Think I've taken a big old samurai sword and we're going to cut this object in half. All right, or cut it anywhere, really, not in half. We're going to cut it anywhere, and that piece that I cut, that is our cross section. Okay, so in this case right here, we have this triangular prism, right? This triangular prism right here, but then I'm going to cut it with this plane. All right, and that's what that shape would look like. Okay. All right, what is the cross section formed by a plane and a solid at the right? Okay. All right, so here I have this cylinder. If I take a cylinder and I cut it right down here, like that, and I take those 2 halves of a can and separate it, what's it going to look like? It's going to look like a rectangle. All right, it's going to be a rectangle. All right. Good. All right, describing a cross section. Go ahead and pause the video and try this one on your own. Okay, got number 4 for the solid at the right. What is a cross section formed by the horizontal plane? Underline the correct word to complete each sentence. So a horizontal plane is parallel to the bottom or the side. Well, it's going to be parallel to the bottom. The view from the side or the top of the solid helps you see the shape. What's the view from the top, right? Okay, so if I do a horizontal plane through here, so that plane right there, what is the shape? What is that shape going to be? That shape is going to be a circle. Okay? All right, excellent. Number 5, drawing the cross section. Draw a cross section formed by a horizontal plane intersecting the left and right faces of the cube. What shape is the cross section? A horizontal plane is parallel to which face of the cube? We're going to circle our answer. All right, so which one is it parallel to? Well, that's going to be parallel to the top and bottom, right? It's going to be parallel to the top and bottom. Circle a drawing that shows the intersection of horizontal plane in the left and right faces of the cube. It's going to be this guy right here, right? Okay, so you can see these lines right there. That's where I'm going to get a cross-section drawn, right? So if I would take a samurai sword and cut right through there like that, okay, then I'm going to get that, and I pull these apart. So I pull this top part and pull this bottom apart. What is this shape going to look like? Well, it's going to be the same size as that and that, okay? So we use the cube to draw that shaded cross-section. All right, so we can draw that in. I kind of already did it in the previous problem, or previous example right up here. So if I draw it in, I'm going to draw here, straight across, and the back. Now, why am I making the back dashed? Why am I doing that? Well, I can't really see it, right? If this is a solid piece of clay, I can't see that line back there. Right? I can't see this red dashed line. It's way in the back of a solid block of clay. I can't really see it. So in this case, the cross section is going to be a square. All right. Now, how do I know it's a square? Well, this is a cube, right? In a cube, we know that all the faces are squares. All right. All the faces are squares. So I know my cross section is going to be one. I'll make it parallel. Okay. All right. To draw a cross section, you can sometimes use the idea in postulate 1.3 that the intersection of 2 planes is exactly one line. So you know if two planes are going to intersect, that their intersection is going to be exactly one line. All right, so that might help you draw this. All right, so go ahead and pause the video and draw the cross-section formed by a vertical plane intersecting the front and right faces of the cube. What shape is the cross-section? Okay, step one says visualize a vertical plane intersecting the vertical faces in parallel segments. Okay, so that's what we're going to do here first. So on this vertical plane, it's going to intersect the front and right face. So this is the front face, and then this is the right face. Okay. Next, we're going to draw the parallel segments. So it's going to be right there. And so that's what our face is going to look like. That's what we're going to get. Okay. So what is the shape of that right there? That's a rectangle. All right. So I know I'm going to get a rectangle. Again, think about this as being a solid block of clay. All right. And you have your clay knife, and you are going to just basically chop off a corner, all right, by putting your knife from here to here and then pushing it down, right? Pushing it down is going to come out right there. So I'm going to have that rectangular piece. Okay. All right. Go ahead and pause the video and complete the lesson check on your own. All right, suppose you build a polyhedron with 2 octagons and 8 squares. Using Euler's formula, how many edges does the solid have? Explain. Okay, so what do we know? The octagon and squares, those are faces. So it's going to be our faces. What do we need? We need to find the number of edges. So our plan is to count the number of edges formed by the square in the top octagon, and count the number of edges formed by the squares in the bottom octagon, and count the number of edges formed by each square. All right? So I forgot to put faces over here too. So the edges of the segments formed by the intersection of the 2 faces. The intersection of the squares at the top of the octagon are going to form how many edges? Well, let's try to draw this actually. All right, so if I draw an octagon, all right, now I'm going to try to draw it in 3 dimensions here, right? So let's see. So there I have an octagon, and I want square sides like that, right? And then I'm going to have my bottom piece. Okay, so now some of those should be dashed. So let me erase some of those. I'm going to make some of those dashed. There we go. All right, so that's some of that dashed. Okay, so think about like an octagon shaped like drum. Okay, so the intersection of the squares and the top edges, those are going to form 8 edges, right? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 edges on top. All right, on the bottom, it's also going to have 8, right? I'm going to have 8, 1, 2, and then I have, kind of didn't show up here in my drawing, 1, 2, 3, 4, 5, 6, 7, 8. All right. All right. The intersection of my 8 squares then, for my edges, my intersection of those, all these dropping down. 1, 2, 3, 4, 5, 6, 7, 8. All right. So there I'm also going to have 8. Okay. So the solid is going to have 8 plus 8 plus 8 edges, which would be 24 of them. All right. Okie doke. All right. Polyhedron. What's polyhedron mean? Poly means many. Hedron. All right. Means bases. Okay, so it means many bases. The face, those are what you can kind of think of the sides of an object. All right. Edge is where 2 faces meet. Vertex is where 3 edges meet, so the points. All right. And a cross section, think about Fruit Ninja. When you're chopping something up, all right, what is the shape that you're going to have? For example, if you have, say, a sphere, we'll talk about those in a few sections. Think about having an orange, all right? If you have an orange piece of fruit and you cut it in half, bam, right there, cut it in half, what's the shape of that going to be? You pull those apart. It's going to be a circle, right? We're going to have a circle. So get an orange at home and cut it in half, pull them apart, look with the inside of the orange, it's circular shaped. Okay? All right, you're now all set to go ahead and do the homework for section 11.1. So go ahead and do that, and I'll see you next time.